Howdy, my name is David Laurel, and today I wanted to talk about a recent project I worked on with file-based database systems in fuzzy logic and Godot in order to create a more organic, in-game dialogue system. So our goals for the project were pretty straightforward. First, we wanted to make sure that we were working with file-based database systems so we could easily port our data from system to system without having to worry about having persistent or portable servers that we would have to connect to. For this, we ended up deciding to go with SQLite as our primary data driver, since there was already support for this system in Godot, and since it made all of our setup as flat as we needed it to be. After this, we had seen some of the existing research on barking mechanics for in-game NPCs, which allowed them to react to their environments. Rather than relying on a strict rule-based approach, however, we wanted our design to feel more organic. For this reason, we wanted to dive a bit into fuzzy logic, which essentially boils down to relying on fuzzy membership functions to define behavior rather than strict rules, and I'll talk more about this later. But before we could do anything with the data on the back end, it became quickly apparent that we would need a base to work with, which could both accept any string we supplied to generate the chat bubbles randomly, called barks, or when interacted with. We spent a healthy amount of the first chunk of this project getting this template up to speed, and we're pretty happy with the results. There's still definitely more that can be done, but for now this should suffice to demonstrate our changes. So these cute little cat characters can be interacted with in-game to produce conversations, or they'll just start barking on their own if you leave them alone. Once we had the general structure of the game ready, and we were able to parse sample messages by picking random phrases from arrays, it was time to build our database for a more persistent and more easily manageable data space, which could hold all of these messages. We tried to make our approach as simple as possible, and avoided any dialogue trees or additional features which could distract us from the actual goal of this project. This database would be considered fairly flat in nature, which is to say that it lacks complexity in its relationships and indices, and even relies on a single file to store all of its contents. Now in some cases this would be less than ideal, but since most of our data will be stored in just a few tables, and the relationships between the tables are generally being called only once for lookup values, this should work perfectly for what we need. Additionally, to ensure portability of our data to any system where we want to port our game to, we were able to utilize infrastructure as code and designed this database file to be created at the time that the game is first run. This might increase startup times by some nominal amount, but in return, we can compress our files even smaller for download than if we tried to compress the database files themselves. Our data is organized into 4 tables with agents and fuzzy factors, acting as lookup tables to match character names to their database IDs, and different factors like time and weather to produce different responses. In theory, this could allow NPCs to respond differently based on the time of day, or even whether it's raining or snowing on a particular day, or any other continuous factor along these lines. Then we store our actual phrases in fuzzy phrases and catchphrases. Now catchphrases is pretty straightforward, with a frequency column determining how often a phrase should be used, to allow for rare speech options. But fuzzy phrases on the other hand has a bit more logic built into the game handlers. But in the database layer itself, the primary difference is that we assign minimum and maximum parameters, which we'll talk about more when we discuss fuzzy set membership. Overall, the data is really compact and allows us to port this information anywhere we want without having to worry about server connections or including complex drivers with our builds. Instead, we used a pre-made package for Godot called Godot-SQLite, which included all of the SQL commands we'll be using. Now it's time to talk about fuzzy logic and set membership. To make things brief, fuzzy logic can be thought of as a way of deciding outcomes to problems whose solutions are a bit, well, fuzzy. Have you ever heard the question, is a hot dog a sandwich? While this might be a bit of a controversial take, the reason the question can't irritate us is because it illustrates the insufficiency of strict rules at defining what does and doesn't belong to something's definitions. One could argue that a hot dog consists of meat, condiments, and other ingredients sandwiched between 2 semi-connected pieces of bread. But others might be quick to point out that with no separation in the bread, things like pizza might even meet this definition too. We even have a similar problem with defining whether Pluto is a planet or not. But back to the topic at hand. Fuzzy logic uses a very clever way to provide an answer to these time-tested questions. Rather than say that a hot dog strictly is or isn't a sandwich, the fuzzy approach would be to say that a hot dog is a 25% member of the sandwich set, while a Reuben sandwich might be a 95% member, and a pizza slice would only be a 5% member. If we had other sets to use as well, like sausage wraps or even hot dog itself, we might be able to say that a hot dog is more of a sausage wrap and definitely more of a hot dog than it is a sandwich, without ruling out the possibility altogether. So how does this relate to in-game dialogue? Well, in our case to demonstrate, we wanted our characters to use phrases which might point out the time of day it is. Rather than relying on a traditional rule-based system which could say, characters should stop using morning phrases after 9 a.m. and begin using evening phrases after 6 p.m., we could make these boundaries a little fuzzier. This is where setting boundary parameters for each dialogue option comes into play. In our database, if you recall, some of our columns included start times and end times for certain phrases, with some of these times even overlapping. By defining membership functions and allowing some randomness to fuzzify our inputs, we're able to generate more organic responses throughout the day. In practice, this is a bit more complicated, but I'll leave the code we used posted and some helpful links in the description in case you're interested in learning more. Overall, this project was a great opportunity to get our hands dirty with file-based database systems, and finally have the chance to use fuzzy logic in a place where it made perfect sense to do so. We're excited for future iterations on this project, and look forward to where this might take us. Please reach out to us at dhlaurel@gmail.com if you have any questions about what we're doing. Thanks again, and I hope you had a great time watching.